Hello, and welcome to the Cassandra upgrade demo. In this demo, we're going to cover how a Cassandra cluster manages upgrading the underlying Cassandra version in a safe and automated manner.
To get started, let's review our environment. Here we already have a Cassandra cluster running. It's composed of 3 Apache Cassandra nodes, each running version 3.11.10. These nodes are also running on separate cloud-managed Kubernetes workers, one node per AZ and a regional deployment. Our target state for this cluster is to be running Apache Cassandra 4.0 with the same topology, one node per rack. And to kick off this process, we're going to take a look at the Helm values used to initially deploy this cluster. So over here, we see our version is 3.11.10, and we want it to be 4.0.0. So we'll just update this field, .0.0, save it, and we will run the command to push this into our cluster. When we do the Helm upgrade command, it's going to handle the templating of the Kubernetes resources and submitting those to the Kubernetes API. We could edit these resources by hand, either through this IDE here or on our disk. But ultimately, there's a CASDC or Cassandra Data Center resource that's going to be updated to reflect the new version number. The CAS operator monitors the CASDC objects, and it's going to set that new version to 4.0.0. With the change in version, it updates the stateful sets, and specifically the template for the stateful set, and then forces the recreation of the pods based off of that template. It's going to do that in a rolling manner, make sure that the nodes come back up before moving on to the next node in the cluster, so you aren't left in a state where your data is unavailable. So it looks like we had a pod restart. That might not be related to the upgrade. Let's see. So we scroll down here. It is related to the upgrade. So here we see version 4.0.0. Our init container has already run, and now we've started the management API, and we're kicking off the bootstrap process. So if we go here to server system logger, we can monitor and watch when that happens. There we go. Now what's going to happen here is it's going to reach out to the seed service, which is a Kubernetes service, and that's going to help it discover the other nodes within this cluster. It's then going to reach out to those nodes and inquire about their status as well as what their view of the cluster looks like and discover all the other nodes. Here we're going to see some messages about connections reset by peer. That's nothing to worry about there, but we just have to wait for the node to finish its upgrade, and then the next node will take its place. One of the nice things about Cassandra is the fact that your data is replicated across multiple nodes. In this case, we're also replicated across AZs. So should a node go down, whether that be for maintenance purposes or otherwise, your data still stays available as multiple replicas are still online. Now, when this node finishes its upgrade process, it's going to receive hints from the other nodes for queries that were received and processed while it was down and unavailable. We can see it's still bootstrapping. It's figuring out where the token values were that it previously owned on disk, repopulating in-memory structures, and we'll see it finish bootstrapping here just in a moment. It's also interesting to check the stateful sets because we can see rack 1, and we look at the pod template spec, we can check the version. There's 4.0, but if we look at rack 2, check its version, it's still 3.11.10. So it's going to make these changes in a rolling fashion.
While you let that run, if you are curious to check out our other demos, I just want to say thank you for attending this demo. Be sure to check out all of our other demos and join us at cassandra.io.